Hey there, Mr. Weaver here, and this lesson is a shortened and combined version of lessons 10 and 11 on both point slope form and standard form. So after this lesson, you need to be able to write an equation in point slope form if you're given two coordinates, and write an equation in standard form. You also need to be able to identify and interpret the x and y intercepts from standard form. You'll know you're successful if, after this lesson, you can write in point slope form, write an equation in standard form, and identify and interpret the x and y intercepts from standard form. The first thing we're going to do is quickly review how to find slope. Now, I'm going to use the graph and count method because we do have Desmos available to us. So I'm going to plot the points. So there is 2, -3, and 5, 9. The graph and count method just says plot the 2 points, and then you're going to count how many spaces you have to go to get from one to the other. Remember to count the spaces, not the lines. So to go from one dot to the other, I would have to go up 12 and over 3. Up on the top, so plus 12 over 3. Reduce that if possible, which I can. 12 divided by 3 is 4. So the slope between those 2 points is 4. Pause the video and find the slope between 4, 3 and -2, -6. Let's check. So if we plot our 2 points, we have 4, 3 and -2, -6. Counting, I would have to go up 9 over 6. So 9 over 6 would reduce to 3 over 2, or 1.5. So your slope was 3 over 2, or if you put 1.5, that works too. Now let's get into our 2 different formats. First, let's talk about point slope form. Point slope form is just another formula for an equation of a line. We already learned about slope intercept form. This form is used when you know the slope and a point, hence the name point slope. In the formula, we have 3 parts to this. We have the slope, which is still m, and we have a coordinate, but it's broken up. So we have the y coordinate as y1 and the x coordinate as x1. The point in the equation is opposite of what you would see as the point. So for example, if you had -2 in the point, it would show up as +2 in the equation. If you had +8 in the point, it would look like -8 in the equation. And we'll look at this in just a second. So let's find the equation in point slope form between these 2 points. So 8, -5, and 12, -3. Let's use Desmos to help us. So I'm going to plot my point, 8, -5, and 12, -3. I can see they showed up on the graph here. If I need to find the slope, I had to go up 1, 2, over 1, 2, 3, 4. So up 2 over 4. So my slope would be 2 over 4, which is the same as 1/2, or 0.5. Now that I know the slope, I can take that and one of my coordinates and start to plug them into the equation. So my equation, y minus y1 equals m times x minus x1. I'm going to plug in the slope, which was 1/2, in where m was. Then I'm going to choose a point. So let's choose 8, -5. And I'm going to plug those into the equation. Remember, they're going to be opposite of what's in the coordinate. So I would end up with y plus 5. The y is the second number of the coordinate. And -8, because x, the first number of the coordinate, was positive. So they are opposites of what's in the coordinate. Had we chosen the other point to use 12 and -3, I would do the same process. The slope would be the same, but my point would be different. Again, we should use Desmos to check. So if I go back and I type in what I think I had, 1/2 times x minus 8. Notice the line goes through my 2 points that I had graphed, telling me that I did the correct thing. If I had the wrong signs, my line wouldn't go through my points, which would indicate something is wrong. Now it's your turn. Pause the video and write the equation in point-slope form for the line that would go through 218 and 644. Don't forget, use Desmos if you need it. Let's check. So the slope, you had to go up 26 and over 4, which comes out to 6.5, or 13 over 2. So if we were to plug those in, we could have y minus 18 equals 13 over 2 times x minus 2, if we use that first point. Or we could do y minus 44 equals 6.5 times x minus 6, if we used 6.5 as our slope and that second coordinate. Again, you should use Desmos to double check to make sure that the line that you came up with does in fact go through your 2 points. And that's all we're going to deal with for point slope form right now. Next, let's look at standard form. So standard form is written as ax plus by equals c. And it has some rules to it. However, there are occasions where you might see it written where it's not following these rules, but they still call it standard form. So in standard form, a, b, and c are integers, so counting numbers, whose greatest common factor is 1. So you shouldn't be able to divide all of them by something. And a must be positive, and a and b can't be 0. That seems like a lot of rules for one simple equation. However, when we're starting to pull it out of context, it ends up not being that complicated. Here's an example in standard form. So we could have 3x plus 4y equals 18. All of our numbers are counting numbers. I can't divide every single one by the same thing. The first number is positive, and the first and second number are not both 0. The second part to standard form is going to be interpreting. The main thing we're able to tell with standard form is the intercepts. Now, we've already talked about the y-intercept, which is where the graph crosses the y-axis, seen here as the pink coordinate. But there's also an x-intercept, and that's where it crosses the x-axis. You'll also hear this called, especially later in the year, as a 0. The x-intercept here is the red coordinate. And just like we've seen before, our y-intercept always has the x value of 0, so it's always 0 and then some number. Our x-intercept is going to have a y value of 0, so it's going to be some number and then 0. They're opposites. When we're interpreting these in context, they have very important meanings. Let's look at writing an equation in standard form. We had lots of rules there, so let's put it together and make sure we can figure stuff out in context. So Hannah will spend $150 on music festival tickets. Reserve tickets cost $25 and general admission tickets cost $10. How can you represent the situation with a linear function? First, define and label what x and y represent. What that means is just something is x, something is y. What are the two things that are happening in the situation? Or what are the two things that you could possibly decide between? We could decide between reserve tickets and general admission tickets. So if I say that x is reserve tickets, that's one of my options. Y is general admission. I also know in the problem that she's going to spend $150. That's important too for our total in our equation. When we start putting this together, we're going to look at what the value of x is and put it with x, and what the value of y is and put it with y. So, x, our reserved seats, was $25. So I'm going to write that as 25x. Y is our general admission. Those were $10. So I'm going to write that as 10Y. And they're going to be combined together because I'm trying to figure out a combination of tickets. And our total was 150. So I would write equals 150. Now, this function by definition is not technically in standard form because we could divide everything by 5. However, for what we need to deal with and figuring things out in context, please just leave it as it is. Pause the video and try your problem. Don't forget to write what X and Y would represent. Let's check your answers. If X is still reserved and Y is still general admission, you should have got 50X plus 20Y equals 200. Notice everything is pretty much in the same format. Something X plus something Y equals some number. And that's generally what you're going to see for things in context. If something's going down or losing money, then it'll be minus that. But most real situations are involving coming up with some total by adding two things together. Next, let's look at identifying and interpreting our intercepts. Before we begin, I did change the total from 50 to 54, so please change it as well. That way the problem comes out nicely for what we want to do. So a high school basketball team scores a total of 54 points by scoring 2-point and 3-point baskets. If the scenario is modeled by the equation 2x plus 3y equals 54, identify and interpret the x and y intercepts. When we're solving this and going through, first we need to define what is x and what is y. So let's say that x is 2-point baskets and y is 3-point baskets. There are two options. If we go to Desmos and type in our function, it looks like this. So 2x plus 3y equals 54, graphed on Desmos. After I've typed it into Desmos, I can click on the places where the intercepts are. So if I click on the point on the x-axis, it's 27, 0. That is your x-intercept. Now, if we're interpreting this in the context, that would mean there were 27 baskets that were 2-pointers and none that were 3-pointers. Because if I think about the coordinate here, x was 27, y was 0. So x is our 2-point baskets, there's 27 of them, and there's 0 3-point baskets. So the x-intercept is all of your x and none of your y. All 27 baskets were 2-pointers and none were 3-pointers. Your y-intercept is the exact opposite. So here it's 0, 18. That is where there were no x values, so no 2-point baskets, and all of them were 3-point baskets. So in this case, there were 18. How do I know how many there were? Well, remember, our total has to be equal to 54 points. If I had any more or any less of that number, it wouldn't come out to 54 points. 18 3-pointers is 54. 27 2-pointers is 54. So your x and y intercepts, they're going to mean the same thing pretty much every time. It's where you have all of your total is by doing one thing and none of the other. Now it's your turn. Identify and interpret the x and y intercepts in this situation. They follow the same pattern as what we just did. Pause the video and try it out. Let's check our answers. Let's say x is 3-pointers and y is 6-pointers, so field goals and touchdowns. If we were to graph it on Desmos, 3x plus 6y equals 24. Looks like this. So your x-intercept was 8, 0, which means that there were 8 x's, so 8 field goals and no touchdowns. And your y-intercept, 0, 4, would mean there were no field goals and 4 touchdowns. That makes sense because we still have to equal 24 points. In this lesson, we learned about two different formats. So first, point-slope form is good when we know a slope and any point. It's written as y minus y1 equals m times x minus x1, where m is still our slope and x1, y1 is our point. And then once we know our slope and our point, we just plug them into the equation. But the point is opposite in the equation. We would plug those in and get y plus 5 equals 3 times x minus 4. Slope is the same as it was before. Point is opposite in the equation. And again, we can use Desmos to help check to see if we're doing stuff correctly. We also learned about standard form, where it's ax plus by equals c. So a and b are usually rates, and c is your total, as we saw with the concert tickets and the sporting events. From those equations, we can find our x and y intercepts. In context, x is the situation where the total is found by only using the x variable and none of the y. Similarly, the y-intercept represents where everything was found by only using the y variable, but none of the x. So for example, if carnival tickets were $2 for kids and $5 for adults, and the carnival made $550, we could say x is kids, y is adults, and then we'd get the equation 2x plus 5y equals 500. In this situation, the x-intercept would be all money made from kids, and the y-intercept would be meaning all money was made from adults. After this lesson, do you know how to write an equation in point-slope form? Do you know how to write an equation in standard form? And can you identify and interpret the x and y intercepts from context when we're dealing with standard form? If you're not sure about parts for point slope or standard form, go back and re-watch those parts of the video to help deepen your understanding. And that's the end of our combined lessons of 10 and 11.